Okay. 2.2 notes, domain and range, real world applications. Okay, so we're doing the same thing we did yesterday with domain and range, except now we're going to have actual problems that look like real life as opposed to just random graphs all by themselves. So here's Chris's trip to school. Notice that this is the time on the x-axis, the domain, and it starts at 0. That's not, 0 o'clock. That 0 is the time that he started when he left home. And the distance from Chris's house is what's on the y-axis. So here's our y and here's our x. Okay, continuous or discrete. All the points are connected because time is a continuous thing. There's points in between the minutes. You can do seconds, milliseconds. So it makes sense that it's continuous. Chris began his trip at 0 minutes, which means whatever time he left the house, that's kind of when the clock started ticking. He ends his trip at 28 minutes, which means it took 28 minutes total for him to get to school. So the domain is going to be the x values in the middle, less than or equal to signs, because there's no open circles. So in between 0 and 28 would be our domain. His minimum distance from home during the trip would be 0 when he was actually at home, and that's miles. His maximum distance from home is going to be right here, which is at 3 miles. And I lied, it was 28 minutes to get to school and back because when he gets home, that's right there. How long did it take him to get to school? 16 minutes. Okay, sorry, side note. So the range is going to be 0, y. So even though he turned around and came back, the farthest away he was 3. So we take the bottom and the top. Remember, we always do our range from bottom to top. Okay. The next graph is dollars and time. So here's the amount of money and here's the time. So the domain is time in this case. And the range is dollars. The domain goes from, and you can draw, remember we talked about drawing boxes on these. It's not as, you don't need to as much with these because they almost always start at 0. So the domain is going to be 0 less than or equal to x, which is the time, less than or equal to 40 hours. And the range is going to be 0 less than or equal to y, less than or equal to $320. So you can make up to $320, but not more. Okay, number 9 is one of those problems where I have to kind of think through it out loud, otherwise I'm going to get confused. So we have ferry boat trips and cars. So cars would be the independent variable. Ferry boat trips would be the dependent variable because the number of ferry boat trips depends on how many cars come. So here's our function. If there are no more than 5,000 cars, that means C has to be less than or equal to 5,000. What are the reasonable values for the range? So this is domain, and range is going to be F. Oh, I'm going to sneeze again just like yesterday. Oh, sometimes I just sneeze for hours. Okay, so if I'm going to do the domain, which it doesn't ask for, but thinking about it, the least number of cars I can have would be 0. So the number of cars has to be between 0 and 5,000. So the ferry boat range is going to be that's if there's 0 cars, or 5,000 over 20 if there's all 5,000 cars, which is the maximum. So 0 divided by 20 is 0, and 5,000 divided by 20 is 250. So the range is somewhere between 0 and 250 ferryboat trips to get 0 to 5,000 cars across. Alrighty. Whoa. Let's go back up to where we're supposed to be. Okay, so here's a graph that shows bacteria growing at an alarming rate, which bacteria tends to do. Okay, so we have the domain is the number of days, and the range is the amount of bacteria. So the domain goes from 0 to, we're going to assume it goes to 10. It probably is like one of those graphs from yesterday where it approaches 10, but we're going to go ahead and call it 10 with that big old dot right there. So 0 is less than or equal to x is less than or equal to 10. What would the range be if we had to have range, which it doesn't ask for the range, but just for fun, the range would be 0 less than or equal to y less than or equal to somewhere up there. We could assume it's probably 1,000, maybe a little bit less. So it's just a little FYI. Okay. Sorry. Okay, here's another one of those problems where we're going to have to work it out and think about it. Okay, so X is gas, gallons, and D of X is miles or distance. So if the fuel tank holds 17 gallons, that's our X. X has to be less than or equal to 17, because if that's how much the fuel tank holds, that's how much you can put in. So reasonable domain would be 0 if it's an empty gas tank to 17. It can't be more than 17 gallons. If that's true, then D of X is going to be between 32 times 0 and 32 times 17. 32 times 0 is 0. And 32 times 17 is 544. Wowie zowie, this is like going to be one of those really quick videos, which means your classwork is going to take a really short time. Hopefully you, wow, I don't know what happened right there. I was going to write domain and range. Hopefully this is pretty easy, straightforward, and you can do this on Friday, the worksheet, and I will have the video up for the weekend so that you can even watch it on Friday if you have time. All right, hasta luego.